We did t-tests, and then we started doing ANOVAs, and the whole underlying mechanism for all this is we are comparing group means. With the Way ANOVA, we compared 3 means. Well, we had 1 IV, and most of the time in the examples, we compared 3 means. Sometimes we compared 4. You could compare as many as you wanted to. With the repeated measures, it's the same person going through that condition multiple times, at least 3, to do the ANOVA. The one we're doing today is a two-way ANOVA, meaning that we have 2 independent variables, and they can have as many levels as they want. We're going to do 2 of them today. One is it's called a 2x3, meaning that we have 1 IV with 2 levels, 1 IV with 3 levels, and then in the second one, we'll have a 2x2. So 1 IV with 2 levels, and the second IV has 2 levels. This is what when we get to the end of it, this is what the first one will look like. And these are the mean ratings by condition and group. And so this is the control group, the dental pain condition, and I'll go through what all this means. Mortality salience condition, and they are rating in-group and out-group members. And so you can just, by seeing this figure, you can kind of see what's going on. It's like, okay, in the control group, the ratings for in-group and out-group are about the same. For the dental pain, about the same. But there's a pretty big difference here between rating in-group members and out-group members in the mortality salience condition. So there's maybe something going on in this one, but not these two. And so that's what we'll get into. Two-factor ANOVA, more complex type, where we're looking to see if there's differences in those population means, like I was just talking about. We're going to have 3 different hypotheses. We're going to have a main effect for the first IV, a main effect for the second IV, and an interaction between those 2 IVs. If we get a significant interaction, then we're going to look and see if we can find significant pairs. Those pairwise comparisons that we did for the Way ANOVA and the repeated measures ANOVA, we're going to do those with the 2-way as well. Remember my final project that I went over? It was the 2x2, the north versus south, insulted versus not insulted. That was a 2-way ANOVA because it had 2 IVs. What region you were from and if you were insulted or not. This was one of the results for that. So in the control group for the north and the south, they were about the same, but when you had insulted people from the south, it caused a change for them. And so it didn't really cause a change for the northerners, but for the southerners, their testosterone went up quite a bit. And so this is a 2-way ANOVA, again, region versus not insulted. And it's like, these are about the same. This one to this one's about the same, but there's something going on right there. That difference between insulted in the north and in the south. With the first example I showed you on the first slide, mortality salience, it's when you remind people their mortality. It causes a unique change in attitudes and behaviors, and one of the things it causes is a stronger intergroup bias where you like your in-group more and you dislike the out-group more. This is how they do it. They have you respond to essays. Please briefly describe the emotions the thought of your own death arouses in you, and yeah, there's the other one, but you're thinking about your own mortality. There's a couple of examples. It's like when American participants were reminded of their mortality, they rated pro-USA essay writers more favorably than anti-US writers. After mortality salience, they were more likely to endorse extreme or even violent actions against outgroups. Christian participants, after they've been exposed to mortality salience, rated Jewish targets more negatively and Christian targets more positively. Exactly what I was saying. It's like your evaluation of the in-group goes up and the evaluation of the out-group goes down after reminders of mortality. Even mortality salience led white participants to evaluate black job applicants less favorably than white applicants. And there's a whole bunch. If you want to look at the literature, there's a million different studies that they've done in that area. Okay, so in this one, let's say we are going to have them rate either an in-group member or an out-group member, and they're going to respond to one of those essay types, either a control essay. They could respond to an essay about dental pain, the thoughts that arouses in you when you go to the dentist, and then the idea of mortality salience. So some of these people would respond to those mortality primes. You would only be in one of these groups. So there's 6 different groups, control, in-group, out, dental pain, in and out, mortality salience, in and out. You'd only be in one of those 6 different groups. The first IV group has 2 levels, in-group and out-group. The second IV has 3 levels, control, dental pain, mortality salience. And then our DV, the numbers that will go in there, is how you rate that person, that target. So you'd be randomly assigned to one of those 6 groups. This is what the data would look like. So we'd have one grouping variable with IV1, so in-group versus out-group, a grouping variable for the essay type, control, dental pain, mortality salience, and then the rating, that's the actual dependent variable from 1 to 7. Main effects, it's the effect of a single factor when you completely ignore the other factor. So we could just look at IV1, the group. We could just look at IV2, which essay they responded to. So if we look at just IV group, we would get our 6 means, right? And then we'd basically get an average or total mean for in-group and out-group and, control, dental pain, mortality salience. If we were to compare that in-group total versus that out-group total, Not even talking about the essay. We're just talking about the total for the in-group and out-group. That would be the main effect for in-group and out-group. And it's like with mortality salience, it increases intergroup bias, but there's already an intergroup bias effect usually at play. It's like people generally do like the in-group more than the out-group. So it's like we would probably have a bigger number for the total in-group than for out-group. On the essay types, so it's like if we ignore in-group and out-group, we're just going to look at how they rated people after they did either the control or the dental pain and mortality salience. You could have a couple different hypotheses there. Maybe they would all be about the same. Mortality salience increases liking of in-group, but decreases out-group. So it's like, it might average out and it might be about the same as the control and dental pain if we're not talking about in-group and out-group. Okay, so we're going to have two main effects in this study, a main effect for group type and a main effect for essay. Then the interaction, it's like, are these numbers going to be consistent across each level of both IVs when you're looking at them together? So the effects of one factor on the DV when you're looking at the other IV. Are they consistent? Because if they're consistent, if they're basically the same, there's no interaction. But if there's something different going on there, then you do have an interaction. Another way of putting it is the product of inconsistent simple effects. And I'll show you the simple effect here in a second. But this is what an interaction would look like. This top one, we're going from 0 to 2 to 4. Dangerous is in black. White is non-dangerous. It doesn't really matter what these mean. But what you can see is that 0, 2, and 4, it goes up. 0, 2, and 4, it goes up. And it goes up about the same amount, meaning that it is consistent across both levels of those IVs. And so there's no interaction there. With this one, dangerous is down here and non-dangerous is up here. But for each level, it stays consistent. It's that far apart at 0, it's that far apart at 2, and it's that far apart at 4. So no interaction. On this one, so black and white are pretty close at 0, black and white are pretty close at 2, but when we get to 4, there's a difference. It's like the white one goes way up here, the black one stays consistent. So this is probably going to be an interaction because there's one level of that IV that's not the same across both of the independent variables. This is another one that's an interaction. This is called a crossover interaction, and it's pretty neat because what it means is like as your independent variables change, you go from here to here or here to here. And it's like it causes this nice crossover. For the black, it starts up here at 0 and then goes way down at 4. But for the white, they start at 0 down here and then they go up at 4. And this is the study I talked about earlier. This is probably an interaction as well because like both of these are down here. If there was no interaction, this number right up here would be down there right by that, right there. But because there's a difference in how these are expressed in each IV there, it's an interaction. The simple effect is if you have like 3 different variables or 3 different levels to that, if you have a 2 by 3, 2 of them might be the same. It's just going to be one of them that's different. That's called the simple effect. And that's exactly what's going on this first one. It's like 0 and 2, almost identical. It's 4 where that difference is at. So it's a significant interaction, but it's also a significant simple effect for that pairing right there. On the crossover interaction, at least in this case, we have 2 simple effects. So this is going to be significantly different from that one, and this one will be significantly different from that one. So we have in the first one, both of these are significant interactions. This one has 1 simple effect, and this one has 2 simple effects. For our culture of honor, we have 1 simple effect. What we would think is that if we have a simple effect with this experiment, it's probably going to be in the mortality salience in-group versus out-group. And so if we're comparing those group means, those two to each other, that should be the simple effect for this one. So putting all that together, main effects, the effect of a single factor when the other factor is ignored, the interaction, the product of inconsistent simple effects, and then a simple effect, the effect of one factor on the DV at a single level of the other variable. We could guess maybe the data would look something like this. So control, for the in-group they have a 4, for the out-group they have for the in-group they have a 5, for the out-group they have a 4. There's a slight increase in liking for the in-group just in the control group. In dental pain, maybe they like the in-group a little bit more than the out-group. And then in mortality salience, this is where the true hypothesis is that for the in-group, we're going to rate them really high, and for the out-group, much lower. If we were to think about simple effects, if these were our actual numbers, it's like, okay, 5, 6, and 7, what's the average? 6, so that's our total. For the out-group, the average is 4, 3, and 2. That would be a 3. We would be comparing 6 to 3 for the independent variable group, which that would make sense, 6 and 3. If these were the actual numbers up here, so to get our average there, 5 and 4, 6 and 3, and 7 and 2, the average for each one of those is 4.5. So at least in this one, there would not be a main effect for control, dental pain, and mortality salience because they're all basically the same. So we'd have a main effect for the grouping, but not for the essay if this was actually our data. On how to conduct this in SPSS, there are 2 slides of instructions. There's a lot of things going on, so definitely look at those and we'll go through it in SPSS together. This is our data, the group, the essay, and the rating. We will click Analyze, General Linear Model, and then we're going to go Univariate. Now I know I said we have 2 independent variables. That's true. Our DV though, we just have 1 DV. That's why it's a univariate and not the multivariate. So univariate, we will move rating to the DV because the rating depends upon which group you're evaluating and which essay you're writing. Then group and essay go in the fixed factor. I like to get the plots, so I would take group and move it to the horizontal and click add. And that's going to give us the main effect for group. Essay, move it to the horizontal, click add. That'll give us the main effect for essay. Then we'll put in both group and essay and it'll give us that interaction. I usually put it in both ways because I don't know which way is going to look right until I actually see it. That's how I do it anyway. So I'm going to put group on the horizontal and essay separate lines, click add. And then I'll put essay in the horizontal and group in the separate lines. So now I have all 4 of those: group, essay, group times essay, essay times group. And then I like to include the error bars. Continue. EM means, so we'll move over group, essay, and then group times essay. That's the interaction. Move it over, get those check boxes, and get Bonferroni. Click Continue. And then Options, Descriptives, and Effect Size. It's pretty similar to what we did with the Way ANOVA and the repeated measures ANOVA. It's just basically you got to know what your DV is, and the fixed factors are the independent variables. Click OK. I like to scroll down to there's a lot of output. I like to scroll down to the images first, the figures, see what's going on. And so it can see in-group and out-group, pretty big difference. Essay type, okay. So control and DP, dental pain are about the same. Mortality salience is a little bit lower. And then our interactions, I can already tell you I like that one better. So let's look at it, the output. These are our group means. So we're kind of close, 5, 4.4, 5, 4.4. Mortality salience, 6.4 compared to a 1.6 for the outgroup, which was kind of what we hypothesized. Our totals, so in group for the main effect, 5.47 versus 3.47, that might be significant. 4.7, 4.7, 4.0, maybe, maybe not. And this would be a table for group means. And then this is how it would look like if you put it in a bar graph. In groups way up there for the mortality salience condition, in groups way up here, out groups way down there. You could also look at it like this in our SPSS output. In groups way up here, out groups way down here, and you'll notice there's a huge gap between the error bars. Doesn't necessarily mean it's going to be significant, but it does suggest it probably will be because that mean difference is not overlapping with 0 in those confidence intervals. You could also look at the main effect for group like this. I should probably have error bars, but there it is, 5.47 to 3.47. On our essay type, I already showed you this. There's maybe a little bit of a gap there. It's not much of a difference though. So it's like maybe it'll be significant, it depends on standard deviations and the N and all that stuff. And then this is our interaction. So now we have both independent variables put together on this same figure. This is control, dental pain, and mortality salience. And in-group is the blue and out-group is the green. So in-group, out-group, and control, about the same. In-group, out-group, and dental pain, about the same. And then there we go. The in-group and out-group mortality salience, pretty big difference. There was a lot of overlap in the error bars. Here, there's no overlap for that one, the simple effect there. This is what that looks like too in the bar graph. So that's just kind of an overview of what it looks like. We have to now go in and get all of our results from the SPSS output. The first one, the group, this is for the main effect for group. We get our degrees of freedom, 1 and 24. Our F statistics, really big, 105, P less than 0.001, eta squared, 0.82, meaning that's like 82% of the variance in how you rate the person depends on which group they're in. And so yeah, there was a main effect for group type. In-group members were rated more favorably than out-group members. And you would list all of those things. Same thing for essay. Oh yes, so we are comparing group, in-group, out-group. That's exactly what that ANOVA is for. This here goes along with this image. Same thing for essay. And if we look 2 and 24, so you're like, okay, well, I was group 1 and essay 2. Just think about it. It's like we had 2 in group, degrees of freedom would be 1. And then for essay, we had 3, so 2. Our F's kind of low, but 5.77 It is significant, so 0.09. The eta squared is not near as impressive, but it's still, if you actually ran this experiment, it's like that would be a good number to get, 0.33. This is the essay main effect. We could, if we wanted to, dig a little bit deeper in there to see where those differences lie. If we did the pairwise comparisons, control to dental pain, control to mortality salience, and dental pain to mortality salience. And what we'll see is that control and dental pain about the same, but it is mortality salience and control and mortality salience and dental pain that they are significantly different in those group means. Bonferroni, post-hoc, significantly different in the control group compared to mortality salience compared to MS, and dental pain compared to MS. But it was not significantly different between control and dental pain. Main effects are great, but the entire reason we're kind of doing this is to see if we get an interaction so we can see if we have a simple effect. This is the image for the main effect. Everything that reported right there, that's what this is. And we were saying that this one is significantly different from this one, and this one is significantly different from that one. Okay, here we are. The interaction. Group times SA. 2, 24, your degrees of freedom. Your F statistics of 51, P less than 0.001, and another A squared of 0.81. Huge. So we'd report that. Then we would want to go see where that simple effect is. So simple effect analysis were conducted. And what we see is in the control group, there's not a significant difference. In the dental pain group, between in-group and out-group, there's not a significant difference. It is the mortality salience group where there's difference between the in-group and out-group. A difference, a mean difference of 4.80, P less than 0.001. It's like, if with our confidence intervals, if we ran this 100 times, 95% of those times, we think that that mean difference should be somewhere between 4.1 and 5.5. So yeah, from the descriptive statistics, that's what we're comparing right there. 6.4 to 1.6. And so 6.4 minus 1.6 is 4.8. And that's what this figure is right here. So again, these were not significantly different from each other, but these are the mortality salience in-group versus out-group. This is all of that written up together. I've mentioned it a few different times now. It's like the first one we ran was a correlation. It was one sentence long. I think it had 3 numbers in it. And this is where we're at now. So it's like, if you made it this far in the course, you're doing quite a bit. This is hard, and this is a lot of stuff. And so if you've gotten to this point in the class, you're doing good. But yeah, these are those exact statements from earlier, just repeated on one slide so you can see what it would look like all together in a results statement. All right, let's do a different one. I have culture, insult, and then dependent variable of we measure aggression in some way. So culture, north versus south. Insult is either no insult or insulted, and then the dependent variable, aggression. Before I do that, though, let's look at the Excel sheet. We get the same numbers, so if you could copy and paste this over, the control, the SA, and the rating, and then added this here. So it's like if it's a group 1, if condition is 1, it's the in group. If condition is 2, is the out group. And for the second one, it's like group 1's control, dental pain, and then mortality salience. And so if you have this information here, it will put all of that in your output, the exact groups. So it's pretty nifty. It's a cool sheet. And you get the same numbers. So on our conditions, the condition, we do get a significant F. Our value for F is significant, and also for SA, and also for condition times SA. I do control in and out. SPSS does every one of them, so it does control in and out, and it does control out and in. I just do one of them because like just flip it in your head. It makes for less output. There was so much output in SPSS, but it's like with this, it's as clean as can be. You could go through each one of those individually if you would like to. This is the one really that we were looking at that we were most concerned about. Mortality salience in group versus out group. But depending on your study, you might want to look at it this way. You might want to look at in group control versus dental pain or whatever it is. I did also create a little area over here where it takes those group means from this chart and then makes a little figure, and it looks just like the one that we saw in SPSS. This is, like I said earlier, a 2x3 ANOVA. We'll do a 2x2 in a second, but you do want to make sure to keep those straight. 2x2 versus 2x3. Okay, so analyze, general linear model, univariate, reset it. We'll move the DV to the DV, and then we'll move culture and insult to the fixed factor or the independent variable. Plots, culture, horizontal, add. Insult, horizontal, add. Culture, horizontal, insult, separate lines. Click add, and then insult to the horizontal and culture to the separate lines. Again, I do them both ways because I don't know which one's going to look right until I actually see it. Include the error bars, click continue. Do your EM means to get your post hocs. So control, insult, the interaction, move them all over, click both boxes and get your Ponferroni. Click continue, click options and get descriptives and the effect size. Click continue, we should be good to go. I'm just gonna scroll down to the bottom right away to see what's going on. Oof, okay. For the culture, the main effect of culture, is there a difference? No, so north and south are about the same, huge error bars. Insult, okay. There's probably a significant main effect there. So if you're not insulted, you are not very aggressive. If you are insulted, you're more aggressive. Of most importance, it's like, okay, is there an interaction? Is there a difference between being insulted in the north versus in the south? Either one of these would work. I'll probably go with this one. I think I like this one better. In theory, you could call this crossover interaction. They do crossover. Insult is the blue one. So in the south, it's down here, and insulted, the red one's up here. So it's like, there we go. This is probably going to be a significant interaction, and the difference between south, insulted versus not insulted, is probably going to be where that difference is going to be at. So yes, I went through that and that. So yeah, that's probably going to be significant main effect, and I think that'll be a significant interaction. Here's our group means. So south, not insulted at 1.8, insulted 5.8. And you can see the north, no insult versus insult, 3.8 to 3.6. It's probably not significantly different on our output. So yeah, what we'll do, we can go right here to the sig, the p-value, and then we'll see that culture, it's not significant. So we do not have a significant main effect for culture, but we do have a significant main effect for insult, meaning that people that were insulted were more likely to respond with aggression than those that were not insulted, which totally makes sense. And then our culture times insult interaction, it is significant as well. We could look at it a couple different ways. This would be one way of looking at it. So in the south, if we compare insulted to not insulted, that's where the mean difference of 4, that's where it's the main thing that we were looking at in this study. This is how we could write that up. So there was not a main effect for culture. There was a main effect for insult. There was a main effect for insult. There was also the significant interaction. Most important to this study, though, is Northerners did not react with more aggression when compared to their control group, the non-insulted group, but Southern participants did react with more aggression when compared to the control group. So the difference of 5.8 and 1.8, mean difference of 4, confidence intervals, and it was significant, p less than 0.001. Again, we get a mean difference of 4 in this one. That should be 4.00. If we ran it 100 times, 95% of those times, we would expect it to be between 2.67, the mean difference between 2.67 and 5.24. Okay, that's a two-way ANOVA. I know it's a lot of stuff, and it's a lot of things to remember, and it's a lot of numbers to try to sift through and find, because again, that output's pretty dense. We will do this one for homework 13. We will do this one for quiz 13, and then quiz 14 is kind of similar to the final test. I do have it on quiz 14 because I do want you to have a little bit more exposure to it. That being said, the two-way ANOVA is not on the final this semester. So at least for this semester, I may consider doing it, adding it in the future, but for right now, let's just get through the analyses that we've already talked about. As soon as I get done with this, I'm going to record a video where I go through practice problems for the final, and you'll see the exact analyses that will be on the final. Okay, great. If it doesn't all make sense, feel free to watch this again. The good news is that this is on video, so you can watch as many times as you need to. All right. Thank you very much for listening.